guys, please. Guys, please. Question 1 is really easy, guys. You shouldn't have problems. All right, let me show you. This is excuse me, guys. Sorry, I'm still sick. This is the likelihood for question 1, guys. Okay, and this can be simplified to this, okay, by simple elementary algebra. The next step is to take the log of the likelihood, which is n log of theta plus log of this term is theta minus 1 times the sum of the log of xi's. Yeah. The next step is to, because you only have one parameter, you need to differentiate only once. Alright, you differentiate only once, and this is the derivative that you will get. You set this equal to 0 and solve for theta, guys. You get theta hat equal to minus n divided by alright, this is the solution of this equation, guys. Now, to make sure that this is an MLE, you will need to do this only in the scalar case, guys. Right, which, I mean, the example that I'm considering here is a scalar case because you only have one parameter. Alright, so you need to do this extra step only in the scalar case. That is, you need to show that the second order derivative of the log likelihood is a negative number. In this case, is minus n by theta squared, which is indeed a negative number. Hence, theta hat equal to is an MLE. All right, so that completes question 1, guys. Is this, I mean, it's not difficult, is it, guys? You got any questions, guys? Rasa? Yeah. Yeah, okay. Can you do question 2, please, now? Question 2 is very similar to this. You okay, ma'am? Any questions on this, guys? Are you okay with this? Yeah? Alright. Can you do question 2, please, now? How do you want to do it? We are doing question 2 now. Okay. That's sort of question 1 I did. Excuse me. You guys done question 2, guys? I mean, you're on? Yeah. All right. Let me show you anyway. Can you guys listen if you haven't done question 2, guys? All right. The likelihood in this case is the product of the density function, which is all right. This is the product of the density function. Now, if you simplify this, guys, you will get theta power 2n, product of xi, I from 1 to n, and e of minus theta, the sum I from 1 to n of xi. Okay? It's really important that you know how to simplify things. And if you look at the course website, I've given you some elementary algebraic identities that can be used to simplify products of likelihoods. So if you have difficulties going from this to this, please look on the website, course website. Right? All right. The next step is to take the log of the likelihood. Yeah, this is the log of the likelihood, guys. The next step is to take the derivative. There's only one derivative here because there's only one parameter. So, okay. And the derivative is 2n by theta minus the sum of xi. Set this to 0 and solve for theta. You get theta hat equal to 2n yeah, and this is 2 divided by x bar being the sample mean, guys. All right, are you with me so far, guys? Yeah. You're doing question 2 now. Yeah. Now, to make sure that this is an MLE, you need to do the second order derivative. The second order derivative is minus 2n by theta squared, which is of course all the time negative, right? And hence theta hat equal to 2 by x bar is an MLE, right? Is this clear to you? Yeah. Good, guys. Any questions, guys? Oh. Can you do question 3 now, please? Can you guys do question 3, please, now, if you haven't already done it? All right, let me show you. It seems some of you are struggling with question 3. Let me show you how to do that. Okay. Right. You are told that x is a normal variable with mean mu and variance equal to 1. And the question is to find the MLE of the probability that x is less than 0. The first thing you need to do is to work out what this is, guys. Right? You need to work out the probability that x is less than 0, which is the probability that a normal variable with these parameters is less than 0. Now I'm gonna do standardization. I'm sure you know what standardization is, right? A standardization is a process where you reduce a normal variable to a standard normal variable, and in this case you do that by see what I've done. I have subtracted mu on the left and the right hand side. Alright, the reason I have done that is because this guy here, what would this be, guys? This would be the standard normal variable with parameters 0 and 1. Okay? And on the right hand side you have minus mu. Alright? And this probability is simply phi at minus mu, right? Where phi phi is the capital Phi is the CDF of the standard normal distribution, right? So what this implies, guys, is that to find the MLE of the probability that x equal to 0, right, what you need is to find the MLE for mu and compute this phi at minus mu hat. Mu hat is the MLE for mu. Now, as you may remember from a couple of weeks ago, or maybe about a week ago, I can't remember now, I showed you in one of the lectures, like when you have a random sample from a normal distribution, the MLE for the mu parameter. Remember, there are two parameters to the normal, the mu and the sigma. The MLE for the mu parameter is, do you guys remember what it is? I proved this in the class about a week or two ago. Guys, I thought you guys have better memory than I do. What's the MLE for mu? When you have a random sample from a normal distribution, the MLE for mu is? Don't you remember this? The MLE for mu is the sample mean. I think I proved this about a week or two ago. If you look back in the lecture notes, the scanned lecture notes, you will see this proof, that the sample mean is the MLE for mu if you have a random sample, right? So here the sample mean is, of course, something you have to compute from the data. So if you look back in the question, guys, I need my glasses here now. Just a minute. Sorry, guys. I just you should read the question, guys. It's x bar will be 1.466 plus 1.791 plus 1.353 up to plus minus 0.237. So all these numbers divided by 8. 8 is the total number of observations. So whatever this gives you, I don't have a calculator, but I won't be able to compute this. So whatever this gives you is the value for x bar, and then you sub this into here and you get the MLE for the probability x less than 0. Okay, guys, so that's how you do. Is it clear or not? So you compute You compute x bar if you have a calculator, and then you submit it here, and you get the MLE for the probability that x is less than 0. Okay? Yeah? Alright, guys. Any questions, guys? Any questions on this, guys? Is that clear to all of you guys or not? All right. Now, what I'm going to do for the rest of all right, can you listen, guys, please? The remaining 4 questions from sheet 4 are for next week. Now, what I'm going to do in the remaining time is, because you may remember last week I did not do all the questions from sheet 3, right? So I'm gonna quickly run through them. The questions I did not do last week, I'm gonna do them now, right? Okay. So starting with, I think it was question. All right, this is question 5 from sheet 3. Can you listen, please? This is I think this is a question I did. I remember doing this question in one of the lectures as an example. So I'm not going to do this now, guys. I think this is question 5 from last week, sheet number 3. This is where you have a random sample from a geometric distribution with parameter p, and the question was to find the MLE. The question was to find MLE of p. And so the likelihood is this. I think on the rest of the details, if you look in one of the lectures I did, guys, please, you will find the rest of the details. So because of that, I'm not going to do that now. Now I want to move on to the next one, which is question 6. Question 6, which is a tricky question, really. I think several had problems with doing this question. This is where you had you have capital N observations. From you may remember these questions, guys. you have capital N observations from a binomial distribution with these parameters 2 and p, right? Remember, a binomial distribution with these parameters has the following mass function, right? This is the probability mass function of this, guys, where the possible values for x are 0, 1, or 2. So, for example, the probability that x equal to 0 is to choose 0, is this, yeah, and the probability that x equals to 1 is to choose 1, and the probability that x equal to 2 is to choose 2, okay. So these are the three possible values the variable x can take, either 0, 1, or 2. And there are n observations. There are capital N observations, each taking the value 0, 1, or 2. And what the question said, you should remember, guys, maybe you already have a copy of sheet 3, I don't know, I don't have one with me. But the question said there are little n0 observations with x equal to 0. And it also said there are little n1 observations with x equal to 1. It also said that there are little n2 observations with x equal to 2. So the total number is n0 plus n1 plus n2, which is equal to capital N. Alright, this is what the question said, if I remember correctly, guys. Yeah, there are capital N observations in total, and out of that, little n0 observations take the value x equal to 0, little n1 observations take the value x equal to 1, and little n2 observations take the value x equal to 2. And the question was, if I remember correctly, is to find the MLE for p. Now, to do that, guys, the first thing you need to do is to write down the likelihood function for p. Now, we know the probability that x equal to 0. We know the probability x equal to 1. We know the probability that x equal to 2. But there are there are n0 observations taking the value. This is just the probability that 1x is equal to 0. But there are n0 observations taking the value x equal to 0. So you need to find the corresponding probability. You need to power this to n0, right? And similarly, this is the probability that a single x equal to 1, but you have n1 observations with x equal to 1. So you need to, the corresponding probability will be this. And similarly, this is the probability that x equal to 2, but you have n2 observations with x equal to 2. So the corresponding probability is this, guys. So the product of these three terms is therefore the likelihood function. Alright? Is that clear or not? Yeah? So that's the most difficult part of the question, is to write down the likelihood. And the rest is just easy. The rest is not difficult, guys. Alright? And this will be 2 and 1 p so this is the likelihood function for p. And the next step, as you all know, is take the log of the likelihood, which will be n1 log 2 plus n1 plus 2 and 2 log p plus 2 and 0 and 1 log of 1 minus p. Alright, this is the next step, as you all know, is take the derivative with respect to p. So you should take the if you take the derivative of this with respect to p, you get n1 plus 2n2 divided by p minus 2n0 plus n1 divided by 1 minus p. Oh, can you see this, guys? No. All right, this is the this is the derivative with respect to p. Set this to 0 and solve for p. You get the following. You get n1 plus 2n2 divided by 2 capital N. All right, this will be the solution of this equation, guys. Now, to make sure that this is an MLE, you need to do the second order derivative, which is the second order derivative will be minus n1 all right, this is the second, which is obviously a negative number because you have a negative here and a negative here, and these are positive terms, and therefore the whole term must be negative, right? Hence p hat equal to it's an MLE. Okay, is that clear, guys, or not? I know it looks like a long question, but the difficult part with this question was to write down the likelihood function, and once you do that, then the rest is not difficult. The rest of the question is not difficult. All right? Is that clear or not? Any questions? No? Yes? I know this is one of the tricky questions last week, in the last week's example class. And I did not have time to do it, so that's why I did it now. I hope this is clear to you guys. Yeah? Okay. Alright, the next question, can I take this away? The next question I did not do last week, guys, is the following. It was this was question 7 in sheet. This is question 7. This is the last question on sheet 3 last week. You may remember, I think it was about right. You guys, this. Do you remember this question, guys? This is question 7. This is question 7 on last week's example class, guys. Yeah, where x is the variable of interest, is the x is the number of men purchasing a certain cereal box, and p is the probability that a man purchasing a cereal box. And it was clear from the question that x has the binomial distribution with parameters 70 and p, where 70 is the total number of purchases, and out of the total number of purchases, 58 were bought by men, and the remaining 12 were bought by women. Okay, and the first part of the question was to write down the likelihood. And clearly the likelihood in this case is the same as the probability mass function of the binomial, which is alright. So this is the probability, guys. This is the probability that 58 of the 70 purchases are by men and the remaining 12 are by women. Alright, so this is the likelihood function. The second part of the question was to find the MLE of P, and to do that, you know what the procedure to follow. Take the log, so it will be the log of this is the log of the likelihood, and take the derivative, set this to 0 and solve for P. You will get P hat equal to 58 by 70. Now to make sure that this is an MLE, once again you need to do the second order derivative. Okay, which is this is the second order derivative, which is always negative because you have minus minus. Okay, so hence P hat equal to 58 by 70 is an MLE. Alright, is that clear, guys? Yeah. So this is part 2 of question 7 last week, guys, which was to find the MLE for P. Alright, you can ignore the part about the confidence interval because we are not going to cover that in the course today, this year. I mean, so just only find the MLE for P in part 2 of question 7 last week. Alright, and the last part of question 7 last week was this is part 3. Right, can you guys listen please? The last part of the question was what is the MLE if P is between half and 2/3? This is 2/3, okay. Right, now how do we do this question, guys? How do we do this last part, guys? Because you are given a restriction on the range of possible values for P, which is between half and 2/3. Now to do this question, we need to use the method I described to you last week, which is the constraint is the restricted domain approach. You may remember, I think I talked about it in the lectures, in one of the lectures. Yeah. So what you need to do is, guys, is to plot L of P versus P. Suppose this is 0, suppose this is 1, suppose this is half, suppose this is, can you guys listen please, suppose this is 2/3, right? Are you guys okay? Yeah. Yeah. Right, suppose this, and suppose your 58 by 70 will be somewhere here. Alright. Okay. Okay, so this I just plotted all the points, right? Now what you need to do is to graph the function L of P versus P. L of P is this function here, right? Once again, it's really important you know how to graph function. As I said yesterday in the lectures, it's really for this course. It's really important you know how to graph things. And if you have difficulties, I can help you outside the class. Not now. if you draw a graph of this, it will look something like this. It will look something like this, okay? And the question here, guys, is to find the MLE of the question is to find the MLE for P if P is between half, that is this point, and 2/3, that is over this range. So you want to find the largest value of the graph over the range from this point to this point, right? Now over this range, what's the largest value of the graph, guys? Over this range from this to this is 2/3, all right there. So it implies automatically that P hat is equal to 2/3, all right? Is that clear, guys? Because when I say restricted domain approach, what you need to do is to graph the likelihood function and look for the largest point of the graph over the restricted range. In this case, the restricted range is from half to 2/3. And over this range, the largest point of the graph is at 2/3. All right, and therefore, this is the MLE. Yeah. Are you guys okay? So this was a question I did not do last week, guys. Are you okay? That's something you get to learn, guys. I mean, I can teach you outside the class, but I'm not sure when you're grasping the function, you learn how to do the course. So, You guys okay? Yeah. Are you all